Here is the review for the quadratics test. So I don't know that I want you to have the exact same example as me, but on the very first day we talked about how these have to be, constant in the x values. And in the y values, and this is just an example, it's the second difference that needs to be constant, and that's how you know it's quadratic. So how do I know it's quadratic? If the second difference is constant. So you need to come up with one there that you can show me is a quadratic function. So write two different forms and explain how you know. So one form we talked about was standard form. And we know it's quadratic because the largest exponent is a 2. Remember, quadratic is an x squared function. And then the other form that we've talked about is vertex form. So that was an x minus h squared plus k. And again, if I FOILed this, you would have an x squared function. And that a, and we talked about this if you have misvote, that a is the same a, but the other letters are different. So again, we're going to decide if things are quadratic and determine why or why not. So we need to look at the difference in the x's. So it looks like here this goes up 1, up 1, up 1, up 1. So that's good because these are all constant. Now let's try these. So this is minus 2, minus 4, minus 6, minus 8. That's not constant, but what is constant is the second difference. So this would be a yes, because the second difference is constant. Is this a quadratic function? Yes. The largest term is x squared. So yes, it is an x squared function. There's nothing bigger than x squared. Number 5, let's look. This looks good. All these are plus 1. So here we go, plus 4, plus 8, plus 16, plus 32. Not looking good because I have plus 4 here and plus 8. So this is a no. The second difference is not constant. Number 6, to determine this, I'm gonna FOIL it, or you could use the box method. But when I take x times 2x squared, I get 2x cubed, and I'm gonna stop right there. 2x cubed is a cubic function, okay, not quadratic. Again, I'm gonna FOIL, so I get 12x squared plus 14x minus 30x minus 35. And I could combine like terms, but I can tell here that this is a yes because it's an x squared and the largest one is x, the largest degree is 2. And this one looks like we're all going plus 1 here. Let's see, so this would be plus 8, plus 8, plus 8, plus 8. This is a no. This one's linear because the first difference is constant for both of them. So graph each function by using the table and label the vertex. So one thing we talked about for Ms. Vote's class is just to pick 5 numbers. And I'm going to start at -2 actually. So -2, -1, 0, 1, and 2. And if we don't get our parabola to turn around and make the whole U shape, then we need to pick more numbers. So if I plug this in, I get, show my work up here, -2 squared minus 6 times -2 plus 5. So this would be 4 plus 12 plus 5. So I think we get 21. negative 1 squared minus 6 times negative 1 plus 5 is to get 1 plus 7 plus 5, so 13. 0 is the easy one because it goes 0, 0, and then 5. If I plug in 1, I should also get, let's see, when I plug in 1, I get 1 squared minus 6 plus 5. So 1 minus 6 is negative 5 plus 5 is 0. If I plug in 2, I get 4 minus 12 plus 5. So negative 8 plus 5, negative 3. And I can already tell it's not repeating. So I might need to pick another number. Let's see what happens here. If I plug in 3, I get 9 minus 12, not minus 12, 9 minus 18, taking forever, 18 plus 5, so I get negative 4. I'm going to keep going. I want to see if I can get it to turn around. So 4, now I'm running out of room. Erase some of this. 4 is, let's see, 4 squared is 16 minus 24 plus 5. So that would be negative 3. Oh, look it. I think I got it to turn around, so I think I know where the vertex is. I'm going to try one more. 5, 25 minus 30 plus 5 would give me 0. So if this wouldn't have worked out, I would have started adding numbers this way, like negative 3, negative 4, because I needed it to turn around, and I found the turnaround spot right now because it's symmetrical. So let's see, 0 over 5 up, 1, 2, 3, 4, 5, 1, 0, 2, negative 3, I'm sorry, yep, 2, negative 3, negative 4, and then it starts turning around. Okay, and I could probably even guess where the next one is, because my axis of symmetry will go right through my vertex. And then I can draw my parabola right on there. When it's in vertex form, it's a little easier. I'm going to choose this middle box to put my vertex in. And I know my vertex is positive 1, positive 3. And that came right from here. Now I'm going to pick some numbers, so like 1, 2, 3, and then go backwards, 0, negative 1. And I'm going to double check my work knowing that this one's going to be a frown because of that negative 1 out front. So I plug in negative 1, I get negative 1 minus 1, which is negative 2 squared is 4, and negative 4 plus 3 is negative 1. When I plug in 0, I get minus 1, which is 1, 1 plus, negative 1 plus 3 is 2. Hopefully this turns around. 2 minus 1 is 1, negative 1 plus 3 is 2, 3 minus 1 is 2, 2 squared is 4, negative 4 plus 3 is negative 1. So we did get that turned around. Oops, I forgot to write 3, negative 4 over here. So I know this vertex is going to be at 1, 3 based on my vertex form of the equation. So negative 1, 0, 2, 1, 3, 2, 2, and then 3, negative 1. And just like I predicted, it opens upside down. If I asked you for the axis of symmetry, you would tell me that it's at x equals 1. So it's given the equation below, find the following information. So the vertex, this one is not so bad, right? I know the vertex right away, 4, negative 8. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. My axis of symmetry then will be x equals 4. I usually can write that in right away. Is it open up or down? 3 is a positive number, so it's going to be a smile. So it opens up. Coordinates of the y-intercept. We can go back to this one. If it opens up, I know that it has a minimum. And that's at y equals negative 8. Okay, because that's as low as it goes right here. Oopsies, right here. The y-intercept, I'm going to plug in 0 to get the y-intercept. So when I do that, I get 3 times negative 4 squared minus 8. This gives me 16. Of course, I don't have a calculator with me right now. 18 through 48. If I'm wrong, I'm so sorry. So that would be 0, 40. And then the domain would be all real numbers. We can put anything in. And the range of the function will be all x's. I'm sorry, all y's greater than or equal to negative 8. That was our minimum. So these kind of go together. Now I need to plot one more point. And since 0, 40 doesn't seem to work, I'm going to plug in, I'm going to try 3. So x equals 3. Because then I get 3 times negative 1 squared minus 8. That's 3 minus 8 equals negative 5. So if I plug in 3, I get negative 5. And then I know that I can just plot the point across from it because we have an axis of symmetry. I know this one's going to be a real tall, skinny one because the y-intercept is 40. Okay, so now going the other way, if I know, if I have the graph, can I kind of work that backwards? So the domain is going to be all real numbers. I can put any number in. But the range is y's less than or equal to 2. It never gets any bigger than 2. If I put in any number, I can never get 3. What are the x-intercepts? Those are right here. If I plug in 0, I would get out 2 or 6. The y-intercept is down here at negative 6. Oops, I did these backwards, didn't I? They'd be over 2 and up 0. I can erase that, maybe. Of course, it's going to take forever. Oh, and I didn't even choose eraser. Good job, me. All right, so I get negative 2, 0, and 6, 0. The y-intercept, if I plug in 0, I'd get out negative 6. The axis of symmetry is at x equals 4. The vertex is at 4, 2. And now I want to write a possible equation. So I'm going to use my vertex form. A x minus h plus k. So I know that this will be 4 and this will be 2. And now I need to solve for a, which I know is going to be a negative number because it's a frown. And I'm going to pick one of these points. So the y-intercept is a good one because I like 0. I always forget my squared here. Okay. Equals negative 6. I'm going to take away 2, so negative 8 equals a times 16 and divide by 16. And I get a equals negative 1/2. And that seems appropriate to me. So I'm going to say y equals negative 1/2 x minus 4 squared plus 2 is an equation of this graph.
Can I try it?
Yeah, do you want to? These are for my students. You want to write your name right here? Show them how you write Cullen.
Okay.
C U L L E and then N. Very good.
Now I want to write your name.
Okay, in just a minute, okay? We have a little bit left. Yeah. So it says, again, we're going to use the graph at the right. The domain of x squared graphs are all real numbers. And the range, this is negative 4, is all y's greater than or equal to negative 4. The x-intercepts of the graph look like negative 3, 0, and 1, 0. The y-intercept looks like 0, -3. So it means, my vertex here is -1, -4. So this is x equals -1 and a possible equation. So my vertex, so I have y equals a x plus 1 minus 4. And now I need to pick a point. I'm going to pick this one. I like to plug in 0. -3 equals a x. I'm not going to use x. I'm going to use 0 plus 1 squared minus 4. 1 squared is 1. I'm going to add 4.
You do C.
And if 1a equals 1, then a equals 1. So I'm just going to write y equals.
And then C. Okay, C.
Okay, you're going to write my name now?
No.
Okay, here you go.
I don't know how you write your name.
K.
Oh, can you write it different?
E.
K. How do you spell E?
E.
What's an E? How do you spell E?
You have an E in your name.
Oh, the same E?
Mm-hmm.
Okay.
Then an N.
How do you spell N?
Like in your name. N.
Like
At the end. The end of Cullen.
The last of my name?
Yep. Oh, that's a U. D.
Oh.
It's okay. You know what a D looks like? Do you know what an R looks like?
No. You can write some of yours.
An A. All right. Back to teaching now. All right. Convert from standard to vertex, or vertex to standard. This is not something we really talked about, but something that I think that you should be able to do based on the factoring unit and the unit before where we talked about polynomials. So, let's see. Did it work? Okay. So, first I'm going to square. So first I'm going to square it. So x plus 6 squared, if we remember our patterns, that's one thing, or you can use the box method or FOIL to multiply x plus 6 and x plus 6. You should get x squared plus 12x plus 36. All of that times 3 and minus 7. So when I distribute this 3 to everything, I get 3x squared
Mommy.
plus 36x plus, I don't know my calculator, 108. And there you have done it from vertex to standard. One more time over here. Okay. First I'm going to, yep, here's a C. First I'm going to FOIL x squared minus 10x plus 25. And then I need to distribute that -2 to everything. Oh, and I forgot this over here. I needed to add that -7. Whoops. So this should be 101 when you're done with it. And this reminded me. And this should be your standard. Oh. All right, so using complete the square. Remember, first I'm going to add 15 to both sides. And I put a plus blank and a plus blank over here. Now I need to determine, let's see, -2 divided by 2 is -1. -1 squared is 1. So what I get here is x minus 1 squared. And I need to put a 1 over here. And then I need to move this back over to get my answer. So this is vertex form. Okay, one more time. I'm going to take the 24 and move it over here using algebra. So I subtract 24 from both sides. And I'm going to add something to both of them. The half of 18 is 9. 9 squared is 81. Add 81 to both sides. X plus 9 squared will be over here. Let's see, 81 minus 24. That'd be 57. I could be completely wrong about that, but I'm using my brain and let you guys know how many mistakes I make. So this would be the final answer here.
Who are you talking to?
My students.